Hello everyone, I am meteorologist Amy Metz, and first I want to show off this new GFS model. Windy.com has a few models it shows, but this GFS just got an upgrade. I posted a link to the information, all reviewing what the new updates are on my Facebook profile, Amy Metz. You can find that too later on today at Weather Woman on Facebook. So here's what it's playing out now. Some of these additions were that there's a curve now with the airplane data. There is some solar radiation input coming in now. So it's getting enhanced. I was always using the European model before because I thought that long-range projections tended to be a little more accurate, but they can go back and forth from time to time. So we're seeing that this low pressure that is associated with all of the moisture and what's showing up on radar now with a ton of lightning that I'll get into in a bit, that is going over Oklahoma, parts of Texas where it's a little more severe, and then traveling northeastward. So that's very likely. We could still have some pop-up cells that get created as the air is flowing south from the Gulf of Mexico and enhancing some of these storms on the southern portion. So that will be something to watch in the days ahead. And I wanted to add in about the lightning. There's been so much. We've had coronal holes coming up into the picture. That's the darker areas here. And each wavelength here in the sun shows something different. These black spots are the coronal holes where the magnetic field lines are actually quite open and able to send more intense, stronger winds through space toward Earth. But there's other effects, other solar phenomena that are also going on right now, and one of them is all the filament with the plasma ejections, where there's actually plasma leaving the sun and coming toward us. So it was just playing out here a moment ago and not wanting to now, but you can still see. I'll zoom in here for you. You can still see this filament that's hanging off of the sun. So in the video, if it were playing, it just kind of moves around. But this sun is now rotating this way, all the way to the right. Oh, so this is getting out of Earth's view and will affect us less and less. But the coronal holes will continue to affect us, plus another active region on the sun that is on this side that is rotating into Earth's view. So that also just erupted a coronal mass ejection. This is magnetically charged gas or plasma, and is another contributor besides these dark spots, the coronal holes, to increasing the solar wind and putting magnetic particles, introducing them into our magnetosphere. So some say magnetosphere, but it's basically a shield that protects our atmosphere on Earth from these extremely energetic particles, relative to what we have on Earth here. And that can bring us auroras. So right now the green is showing that it's not a high chance for aurora. If you start to see the yellows and reds, it's higher chance, but this is only going over the next 24 hours. There have been some higher values of geomagnetic storming where we see the red, and then moderate levels of geomagnetic storms in the yellow over this past few days, and that's going to keep happening for the same reasons we just saw above. Our proton level is nothing to be at warning levels for, but all of this stuff has an effect not only on satellites, people, and communications, but on our weather. So that the new GFS model, or at least the updates to it, will start to add in some of those radiation effects to our clouds, because I have read plenty of studies where those sorts of solar storms, when they interact with our magnetosphere and they come close toward us, it will increase cloud cover, it will intensify pressure systems, and also give us a lot more lightning. So this right here could get a little bit more intense also because of solar forcing, and now GFS will be telling us that. So the ingredients for severe weather are that we have deep moist convection. This is the moisture we're looking at. Green and white is moisture in the upper levels. Now if we go to the mid-level, again, green and white are the moist areas. So in order to call this deep moisture, then we'll see the moisture at every level, which we do. So this is continuing also in the lower level of the water vapor imagery. So we have deep moisture. How about the convection portion? So clearly there's convection, we can see just looking at radar. But I'm going to go one step further for the forecasting portion of this, and using weather.cod.edu. This is a great site, has a lot. I'm right now under the RAP meso analyses. And so here we get an idea, like a very wide view of things at different levels. So up on top, we're seeing higher levels. One thing I like to look at first is how are the jets looking? If we see these lines going away from one another, that's going to create some of that convection, the upward motion. So deep moist convection is definitely going to be undergoing. These colors you're seeing here represent the speed. Would be a jet streak right in the middle. And then some of these exit regions can oftentimes have the more severe weather. And the big reason for that is that there's upper level divergence. Those lines of constant pressure are diverging away from one another. So in this case, that can allow air from the ground to lift up. And when it lifts up, it typically cools and condenses most of the time, depending on atmospheric conditions. And in this case, it will be. So at that same level high in the sky where the jets fly around there, we're looking at red as well. So that's another indicator that we're getting some divergence here. You can see in the bottom right, we're looking at divergence now in different values, but the red zones will indicate that, again, we're having a lot of that ability for the sky to open up at top, in the higher levels, and then let more storms form. And at the 500 millibar, when these systems are stacked like this, we saw also higher in the sky at 300 millibars. The low was really in the same place. Divergence in this case is a little bit more over Oklahoma, but still continues in the same region here too. So that would tell me that these storms can spread out a little more. And then for forecasting, I'll go back here and look a little bit more at temperature advection. So we're having warm temperature advect. Remember I said over the Gulf of Mexico, which is right here. When these winds become southerly, coming from the south and moving north, they tend to pick up moisture and pop up storm cells. So the more that this low pressure tracks, now we're looking a little lower, so it's not completely stacked, by the way. This low pressure was about here, 300 and 500 millibars. Now we're at 850, a little bit closer to the surface. It's a little off. So that kind of says to me that it's not going to be as strong. At least this is one parameter to say that it's not as strong as it could be, like last week. But we do have warmer air over the Gulf that will be moving north, and that alone can produce more strong storms as the low tracks east. And in this case, there's quite a bit of opening up between these lines to the northeast. So things are taking the path of least resistance here. That's how things tend to work in natural systems, including the atmosphere. So I could agree, just looking at data alone, that this storm will likely be tracking toward this way. And also when we have low pressures next to one another, oftentimes as things evolve, and let's say a system from over near the west coast, the northwest, as we've been trending, having these long wave patterns and storms here, as this begins to move east and all these lows move east, sometimes they'll couple together. So with all this space here and 3 low pressures, a lot of gapping between these 2 isobars, I would not be, or iso heights, excuse me. Never mind, they are, here we go. Yeah, it's the heights here that I'm looking at. So, but the gapping is synonymous still with the idea that these low pressures will want to move toward one another. And perhaps we'll be seeing fewer L's on the screen in the days to come, and it'll be more centered toward the north and then northeast as things evolve in the next day or two. And as that happens, this warm air advection will continue tracking across the Gulf and bringing some more severe weather possibilities pretty close to the low pressure. So maybe not as south as we saw with the last tornado outbreak, but a little bit more to the north. And again, I don't believe it will be as intense as what we just had. So with moisture that's available at different levels, like we just saw on the water vapor, you can also look at that here. We saw a lot over Texas, quite a bit over Oklahoma, and now that we're looking at just one lower level of this on moisture with where the green is a certain level of moisture with the dew point spread from the temperature. Yeah, we can see already that as this low pressure tracks east, more moisture will get pulled up. That can create storms. So the more daytime heating you have, the fewer clouds, the higher chance there is for this region here by Tennessee, the northern mag states. There's a little more chance that there could be stronger storms, but luckily there has been quite a bit of cloud cover. One of the mechanisms with that solar forcing is that there will be clouds. So these white, they're kind of wispy. These ones here are cirrus clouds most likely. And there's other ways I can look at this, but I'll use the infrared for now anyway. We know that all these colors and the whites are different kinds of clouds. So the good news here, and one reason why I'll say that it probably won't be as severe as what we just had, is that there is a lot more cloud cover ahead of the main line of storms right here. So the main temperature gradient has a lot of cooling that will occur ahead of the passage of this entire system. So there could be strong cells popping up here, but with these clouds giving you a little bit more cooling on the ground, we'll be a little bit safer than I think we were last week. So I hope everybody is prepared and can enjoy the weather. You can look in the description down below and get tips on how to stay prepared for tornadoes, what that means. And I'll go ahead and play out in the visible spectrum the last 12 hours so we can kind of get an idea too of how that latest solar activity may have affected our cloud cover. It looks like my internet is being slow today, but here we go. So there's diurnal effects too, where you'll see the sun come up and bring a few more clouds about, but it looks to me like there were quite a few clouds, even globally, that they do appear to have increased a bit, and that does go along with a lot of the newer data I am seeing now that we have a lot of solar instruments out in space. Some of them have been there for a little bit, but a lot of them are very new, just like a decade old. So we're going to continue to enhance our warning systems, our data products, and forecast models. I'm excited for this and for the new additions to the GFS model. So enjoy the weather, stay prepared, and I hope you all have a nice day. This is meteorologist Amy Metz.